we have the convex, and we have the concave. So those are the two major types of lenses. And the first one we shall look at is the convex. Let's look at the convex. The convex lens. So the other name for convex is also known as, we call it the converging lens. So also known as the converging lens. So it's also known as the converging lens. It's the same name. Their physical properties is that they happen to have a thick middle, and then they are thin at the edges. All right. So please let's note that they have a thickness, or we say here they tend to be thick at the middle and thin at the edges. Now, the other thing is that all rays which are parallel to the principal axis, they converge. We can say they meet, or they converge. They converge at the focal, we call it, or the principal focus. They converge at the principal focus. At the principal focus. Now, the distance between the principal focus and the middle of the lens, what do we call that? Or the center of the lens? The focal point. Very good. So we note that one down. We say the distance. So the distance between the principal focus and the center of the lens is known as the focal length. The focal length. So be able to see that. So we have another terminology here. We're calling it the focal length. All right, we're gonna have a sketch for that. Okay, so let's have a sketch for that. This is what we call the concave lens. You can see the center tends to be quite thick, and the edges tends to be quite thin. And then the straight line that moves all the way from both ends through the center to the other side. This line is the one that we call the principal axis. This is the principal axis. All right. Now we said already, if all rays which tends to be parallel, so this is the center of the lens. So if we can draw rays that tend to be parallel, let's draw them on both sides. So all these rays they are parallel to the principal axis. So all of them would converge. At this point, we are calling the principal focus. Please use a ruler to do this. So all of them, they move and converge at that point. We call the principal focus. And we said between the center of the mirror all the way to the principal focus, the focal length. Let's talk about the concave now. So they are also known as diverging lenses. Now they are thin at the center, and then they tend to be thick at the edges. For this one, all the rays parallel to the principal axis. So they tend to diverge outside. Hence the name diverging lenses. All right. The point from which they appear to diverge, that is spread out, is known as its principal focus. That point from which all the rays will appear to be diverging from or spreading out from. It's like they're coming from a center and then spreading out. That point is now what is known as its principal focus. Now we say the line that passes through the center line is the principal axis. It's not an existent line, it's an imaginary one, it's not there. All right? So that we can do a lot of drawing referencing that line. All the rays will appear to be coming from that point we are calling the principal focus. And something to note here, the principal focus is on both sides of the mirror. Just also with this one. Here we had the principal focus F. Still on this other side, it will be equidistant from the center. So from the center, same range on this other side, we'll have also the principal focus. So can be, we are saying now all rays, they appear as though they are coming from the principal focus. So I'll draw some rays. Now, these ones, please note, the real rays, of course, they were just moving parallel to hit the mirror. So parallel like this to hit this mirror. And then we have this other one. And we have this other one. So these are the rays which are just parallel to the principal axis. So all of them, they will diverge outside and then appear as though they are coming from a point which we are calling the principal focus. Those are the two lenses. I mean, we have this is the concave, the other one was the convex. Something you may realize is that due to those differences in the physical appearances and the behavior of rays once they hit the mirror, we're going to have different images or properties of images. Of course, we're going to see different images formed with different properties depending on where they are. Well, if that image is beyond the focal point, then it will have its own characteristic. If it's at the focal point, or when it is done between the center of the mirror and the principal focus. Again, the same thing happening here. If the image is beyond the focal principal axis, the principal focus, or whether it's at that point beyond or between. So we are going to have different properties. And then that also causes a mirror like the convex mirror to behave like a magnifying glass. We'll see that property and how that happens.